Warning, the video you're about to watch contains mathematics at the level of differential calculus, also known as Calc 1. All material has an assumed prerequisite of pre-calculus and a full semester course in trigonometry. A thorough review of prerequisite topics can be found by searching the web.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcome.
Hello, my name is Roy Simpson, professor of mathematics at Cosumnes River College in Sacramento, California. In this video, we're going to go ahead and use the lemmas that we just proved in the previous video to evaluate some limits. So again, just to remind you, those lemmas are the following. So we're going to go ahead and use them right now. So way back when you first encountered limits in calculus, you did not play around with sign functions that much. One of the first ones that I give my students, honestly, is sine of theta over theta. I start with that because I just want to showcase that that does mechanically turn into one if you use a table or a graphing calculator or Desmos or something like that. But now we have to evaluate something like this without using technology. We have to do this by hand. And notice this is not sine of theta over theta. This is where the adherence to rigor in mathematics is critical. We have a theorem that says, man, if that was the limit as theta approaches 0 of sine of theta over theta, well, I know that limit would be 1. Unfortunately, this is not that limit. However, there's nothing stopping you from making what's called a U substitution. And that's usually reserved for later on in a calculus course, that phrase. But I actually use that in my trig and pre-calculus courses to get students used to the phrasing of a U substitution. It doesn't have to be the letter U. You can use any variable you want other than theta because it's in use in this problem. But I'm going to let U equal 3 theta. And the reason why I want to do that is so that I can trade out this argument in my sign for a simpler argument of just U. Of course, that means I want to trade everything in this limit into the world of U's. So I'm just going to say this will imply that whenever I see a theta, I want to replace it with a U over 3. That okay? That's okay with me. Now, one little thing that I need to mention here, as theta goes to 0, U over 3 goes to 0. That should make sense. So we can at least say that that is true. And more specifically, we could say this implies that U must go to 0, as, again, theta is going to 0. So that's going to be critical for our evaluation here. So let's see, we said that this is going to equal the limit. I'll leave the designator underneath the limit blank for now. We have the sine of 3 theta, which we're calling U, and theta, remember, was U over 3. Now, theta's tending to 0, but as theta tends to 0, so does U. So U tends to 0 just as theta tends to 0. And multiplying both numerator and denominator of this fraction by 3, you'll get the following. 3 limit as U tends to 0 of sine of U over U. And that ratio, we already know what happens with that because we've proved that theorem. It's written right up above, in fact. The limit as U goes to 0 of sine of U over U is equal to 1. So this is 3 times 1, or 3. That little U substitution is very powerful in mathematics. And the only piece that's kind of wonky here is saying, well, as theta goes to 0, U goes to 0. And it's true. It is true, though. I'm not lying when I say as theta goes to 0, U goes to 0. So the main thing that you have to worry about is substituting in for these pictures right here. And then as long as theta goes to 0, it will cause U to also tend to 0. So our entire setup is still very valid. Let's try that again. Let's do another example and make sure that we're getting this. Evaluate the limit. As x approaches 3, sine of x minus 3 over x squared minus 5x plus 6. That looks to be a limit you would not be able to evaluate in the past, but you can do so now. One thing I would highly recommend, perform algebra before calculus. So this would be the limit as x approaches 3 of sine of x minus 3 divided by x minus 3 times x minus 2, right? So what do you do here? Because you'll have division by 0 if you try to do a direct substitution, and your numerator would also turn into 0. That's a problem. 0 over 0 is a major problem in calculus. So what do you do? Well, same trick we did before. We're gonna go ahead and off to the side say let, and I'm just gonna trade out this argument for the letter u. So let u equal x minus 3. Great, that's perfect. And now I should also mention that will imply that x is equal to u plus 3, but I'm not really gonna super use that, but it is true. And from this top one, right here, as x goes to 0, well, u goes to 0. So let's go ahead and do our replacements. Oops, sorry, not as x goes to 0, it's as x goes to 3. As x goes to 3, u goes to 0. Sorry about that. So as x goes to 3, you could see that if we take the limit as x goes to 3 of x minus 3, that will result in u becoming 0. So replacing this information within our limit, we have the limit. I will leave the under part of the limit free for now. We have the sine of u, because u was x minus 3, divided by u times, again, x is equal to u plus 3, and then minus 2. And now we could say u is heading to 0, because as x goes to 3, again, u tends to 0. And notice here that this can be written as the limit as u approaches 0 of sine of u over u times the limit as u tends to 0 of 1 over u plus 1. Sine of u over u as u is approaching 0 is 1. And the other factor here, we could just do direct substitution, and that will be a 1 as well. Thus, this limit is 1. It's a really good use of that lemma. A very, very powerful use of that lemma, in fact. Pretty much all the examples run like that, and here is yet another version of it, but they're all basically the same example over and over again. You have this limit as x approaches 0 of the cosecant of x times the sine of x. Well, first thing I'm going to do is, if you can do direct substitution, you should, but you cannot. If you allow x to be 0 here, that's perfectly fine. Sine of 0 is 0, and then again, sine of 0 is 0. That's okay. But the cosecant of 0 is not defined. So that's a problem. So we can't do direct substitution. It would be terribly wrong of you to say does not exist without trying anything. So what you want to do is try some old school, in this case, trig. Just do a little trig here. This cosecant is 1 over the sine of x, and it's being multiplied by sine of x. And I'll just do the same thing. Actually, let me clean this up one step further if you don't mind. X goes to 0 of the sine of x all over the sine of x. And I'll do the same thing that I did in the previous examples. I'm just going to let u be the argument of that sine function. So let u equal the sine of x. And as x goes to 0, so you could even write it like this if you wanted to, limit as x goes to 0 of sine of x, well, that's 0. That is, as x goes to 0, sine of x goes to 0. So that's perfectly fine. And by the way, sine of x is u. So as x goes to 0, u is going to tend to 0 because u is sine of x. So we make that replacement here. This will be the limit. Instead of as x goes to 0, we'll go ahead and now say it's u going to 0. Sine of u over u. And we know that's going to be 1 by design. So all my examples in this video have involved the sine of x over x, or sine theta over theta, whichever you prefer. Very similar arguments if you're dealing with the cosine minus 1 over theta situation. In those situations, generally they involve summations or differences of trig functions. But I didn't really set up an example for it, but you can use this as a template to kind of help you through those styles of problems. They're all the same thing as sine theta over theta as theta goes to 0. Same ideas.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way. Cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Says, listen close. Don't talk too much that isn't kosher. You may really hurt inside. It doesn't justify you to speak too loud and cry.